PA9, this is also the last goal and assignment. What you'll be asked to do is very light. Simply extend your web file server such that it's secure. Now, by secure web file server, I meant that your web file server there exchanging HTTP messages with the client. All these messages will be encrypted so that any hackers, in the middle of the internet somewhere, after sniffing the traffic, examining the content of the packet, will not be able to see what you want to say with the remote process, with the client process in plain text. And that is not very hard to do. You will need to learn a couple more APIs, but very straightforward. So after calling these new APIs, what you'll be creating are the secure sockets instead of the regular sockets. As a result, the messages you'll be sending out would all be encrypted. And that secure socket is called the TLS socket. Now, TLS we've already introduced in Chapter 2 when we were talking about the QoS, quality of services. So one of the 4 quality of services that we might need to provide for application need is security. Okay, and that is when I talked about TLS. So it's the support there in the application layer, but right above TCP, the transport layer, and right below the application process. So it's application process, TLS, TCP. Okay, so it belongs to the application layer, but it's at the bottom of the application layer. Okay, as a result, at the application process, you generate message, you push it through the TLS socket. The TLS socket encrypt the message before it passes further down to TCP, pass further down to IP. Okay, so the hackers in the middle, even though they intercept the messages, it's going to be encrypted anyway. They will not be able to see, okay, what is the secret you want to transmit to the remote process. The thing is that this encryption is done using a shared key between the sender and the receiver. So the client sending requests will need to encrypt the HTTP request messages. The web server there sending the response will need to know the shared key to encrypt the HTTP response messages. Okay. The problem is, right? Yeah, the client can generate the shared master key, but how does the shared master key get to the hands of the server, right? Otherwise, the server does not know how to decrypt the encrypted HTTP request. Server doesn't know how to encrypt the HTTP response messages that needs to be secret. So, yeah, there's an issue distributing the shared master key. And that is what's magic in TLS. So, yeah, the connection using a TLS socket is actually separated to the key establishment phase to the data phase. So in the key establishment phase, yeah, this master key, okay, is distributed without anyone else knowing. Now, when the server and the client both have the shared master key, then in the data phase, they use the same shared key to encrypt all the messages. So the magic is right there in the key establishment phase. The way it works, however, is not that hard. It's only a 3-way handshake, just like establishing the TCP connection. The client here, being the one initiating the connection, sends a hello. That's plain text. And there's nothing secret about the hello message. Okay, it's just that, hey guys, are you there? Okay, server there, being present, sends back a message, and that message doesn't need to be a secret. In that message, it contains the server's public key. Okay. So by public key, what it meant is that this key can be well known by everyone in the world. Okay. So client here will see, oh, server's public key, cool. And then here, this is the magic. The client here sends the master key, but the master key is encrypted using server's public key. Now, when that message arrived at the server can decrypt the message using the server's private key. Now, server's private key is private. Only the server keeps it. Okay, no one else on the internet knows about the private key. That's guess what? The master key being encrypted by the server's public key is kept a secret, and only the server will know what the master key is. And this is done by the magic of this public key system, where if you have a message that you encrypt it with the public key, only the private key can decrypt it. If you have a message encrypted using the private key, only the public key can decrypt it. And so the server there needs to have a pair of these keys, the public key so that it can send to the client, the private key such that the master key coming from the client can be decrypted. And that is what I meant here. You need to set up the public and the private key file, okay, when we call the TLS socket establishment API. And no worries, Poly has already created the key pair for you. So server.ser here is the public key. Server.key here is the private key. Okay. So you just download these two files and put them into the pa9 directory where you'll be working in for the examples to come and for the pa9.go, okay, that you will submit.